Okay, we're doing a little bit of review for the complex numbers test. Test is tomorrow, so be prepared. First up, this problem. This is the third root. It's been set up as a third root question. But I would do several modifications first. Number one, I would remember that there's going to be three third roots. Number two, I would put it in cis form. If you haven't already, put it in cis form, and I'm going to show you how to do that for those at home that may need a review of that. So if I go over 1 and I go up root 3, I don't know how far root 3 is, but I'm going to say it's that distance. I'll put a dot right there. Remember, that's a dot in space. It's not a triangle. But I can draw a triangle around it to sort of help me figure out stuff. Like that's square root of 3, that's 1. Oh, I know this triangle. It's the 1, 2, root 3 triangle. And what's across from the root 3? People do this wrong all the time, and they say, oh yeah, it's the 1, 2, root 3 triangle. It must be a 30-degree angle. No, the one that's across from the root 3 is a 60. Okay, so if you did a pi over 6 this whole time, no. It should have been something cis pi over 3. And what's the radius on this guy? 2. How many of you use the proper angle, or proper cis? 2 cis pi over 3. Okay, good. Then we're going to say plus 2 pi k. Why do we have to do that? Because we will use this to generate our extra answers. Then I'm going to put this to the 1/3 again. And this is an example of using de Moivre, which is all about the move of the exponent. I'm putting a ton of 1/3s up here. Why? Because I need to put one here. And yes, I gave you one that was nasty. It didn't come out to a nice, but I need you to get used to that. They don't always work out nice. 2 to the 1/3, cis. Then I'm going to bring down another one of these 1/3s and put it here. Another one of these 1/3s and put it there. Now, if I'm going to do the case where k equals 0, then this whole part drops out. I don't have to worry about it anymore. I've already distributed my 1/3s. And then this is pi over 9 plus 0, which is just pi over 9. Raise your hand if you had the first one right. All right. Next, I would add something. For the next one, it's 2 to the 1/3 power. Cis pi over 9 again, plus something. When k equals 1, I'd put a 1 right there, which means one of those, which is 2 pi over 3. But that's a pain to add. 2 pi over 3 doesn't add nicely because it doesn't have a common denominator. So I'm going to times by 3 and times by 3. So did you add 6 pi over 9? Every time. All right. So if I add 6 pi over 9 to the 1 pi over 9 that I had before, that will be, this all simplifies down to 7 pi over 9. And then I would keep going like that, add another 6 pi for my next answer, 2 to the 1/3 cis, and it was 7 pi over 9, adding another 6 pi over 9 makes 13 pi over 9. And why should I stop? Because the next one, if we simplified it down, would actually end up being the same as the first one. So I got my 3/3 roots, and I'm still going to lose a point. Why? Which of these has gone past pi? That third one. It went past pi. How many of you noticed that it went past pi and you need to fix it? Good job, 4 of you. Okay, remember, you're not supposed to leave your answer that way because it went past pi. So if you think about it as, how far past pi did it go? Well, here would have been 9 pi over, 9 pi over 9. And it went to 13 pi over 9, so it went an extra 4 pi over 9 more than it should have. Another way to think of it is, when I hit 18 pi over 9, that would have been 2 pi. So how much more did it need to go when it was at 14? Wait a minute, 13 pi over 9. So hold on. This was at 13 pi over 9, sorry. Then how much from 13 to 18? That is 5 pi. Those, they did it right and knew that. Was it 5 pi over 9? Is that right? Okay, good. Changing that to negative 5 pi over 9. Because you can't give answers that are in here as positives. You have to use negative angles in there. Easy to forget. Okay, so there's the 3/3 roots type of question. Next, what if I just simply gave you a great big nasty polynomial and said, don't just factor it, that's what you did last year. Factor it over with complex numbers. How is that any different? Well, for example, you would not want to leave an answer like that as factored. In the old days, we would have said that was factored as far as it could be because we didn't deal with complex numbers. Now you'd have to factor it all the way. All right, so if you were going to do this one, I purposely made it a 5-parter because then you can't do factor by grouping, which I know some of you guys' main way of factoring. It's a good way, but this way, this kind requires you to know long division. But in order to do that, I need to tell you one of the roots, so I will. One of the roots is I. That tells you a lot right there. Since I said one of the roots is I, you should be able to finish factoring this thing all the way. And that includes over the complex numbers, as in don't leave an answer with x squared plus 4 in it, because that could be factored further. All right, use long division. But the thing that's going to be challenging for some people is they're going to be like, well, he said I, so do I put an I there? No. You have to think about it more than that. You should know some of the factors already. Since I said I was a factor, I is a root. Then you should know a factor that goes with that. You know a lot of stuff, actually. All right, on a pause while you get some time to give that one a try. So it's a really good thing I caught this early. That's a 2 at the end. I'm sorry, I didn't catch it early, but I caught it. So, long story short, here's the thing you should have been able to do. Okay, I get that this one didn't factor nicely, but here's what you should have at least known. If I was a root, did you automatically know that x minus I was a factor? Were you that smart? Because you should have been able to do that. Even with the flawed problem, you should have gone there. And the next thing you should have said, well, if I is a root, then negative I is a root. Why am I putting x minus? Because you always put x minus. And then if the root is negative I, you go x minus negative I, and of course that changes to plus. All right, then you should have been able to say, okay, so you're saying, Mr. Server, that x squared plus outside inside cancel, and this will be negative I squared, which means negative of negative 1, which means plus 1. X squared plus 1. How many of you got that far? And then you went to long division, and it was only at the very end when it didn't work. X squared plus 1 into this whole thing, x to the 4th plus 3x to the 3rd plus 3x squared plus 3x plus, oops, 2. I shouldn't have said 3. Okay, then we'll put at the top an x squared, multiply it out. I better do this just in case kids don't know how to long divide. X squared times x squared, this times this, makes x to the 4th, and then x squared times the 1 makes 1x squared, but I'm not going to line it up here because that's where the x to the 3rds are. I'm going to line it up here, 1x squared. Draw the line, and remember to make these opposite of what they were. Now I can bring down the 3x to the 3rd because really I'm adding 0 to it. And then I have plus 2x squared. And then I go up to the top again and say what needs to go here next. I want it to be a plus 3x because 3x times x squared will make 3x to the 3rd. And then 3x times the 1 makes plus. And again, I don't want to line it up here. I want to line it up over here. So it lines up well with this other 3x here. And then when I subtract, this will make 2x squared. You could say plus 0x squareds if you wanted to. And then that cancels and it's gone, and there's only this 2 left. And it was only at the very end of the problem where you should have gotten like, whoa, not working. But now it should. Final answer, plus 2. 2 times x squared makes 2x squared. Move this up. And then 2 times the 1 makes 2. Draw the line, opposite, opposite. And I have a 0 at the end, which means it worked. Yay. Okay, so here's a typical answer kids write, and they're like, sweet, it worked. I got that one right. And no, you're going to get it wrong. Why is that not okay? It's not factored all the way. It's partway factored. Would you please, since you didn't know it was a 2, you may not have had it that far, take it from there and finish it, because that's not right. That's factored partway. Factor it all the way. Now pause for a moment while you factor it completely over the complex numbers. Is there a mistake in there? You're looking at it so intently. Okay, all right, I don't think there's a mistake in there, so I'll pause for a moment while you work. Okay, judging by body language and stuff, I think you guys are done. You should have said x plus I and x minus I for this first part, because even though 1 doesn't look like it can factor, it can, because it has square roots that are nice. And the square root of 1 is just 1. So it's 1i and negative 1i. And then the last part, this part factors too. Did you know that? X plus 2 and x plus what? Doesn't it? All right. Okay. It's factored all the way. Not just across the real numbers, it's factored across the complex numbers. That's the whole point. It's why it's in this chapter of complex number questions, because we factored it across the complex numbers. All right, let's back up a notch and just take an easy one. If I label R as being 1 plus I, and I label Z as being 1 minus root 3i, I'd like you to tell me what R times Z with a line over it means. If you know the symbology, you should be able to tell me what happens when you take R times Z with a line over it. If you've forgotten what that is, I'll tell you in a minute, but I'll give you time to process. Okay, by now you either know what that little line over it thing means or you don't. You may even know what it looks like, but do you know its name? If I was going to do Z with a line over it, it's actually conjugate of Z. How many of you knew that? Okay, good. Then that means 1 plus root 3i is the conjugate of Z. And that means I'm supposed to take 1 plus I and times it by 1 plus root 3i. I think it'd still be good practice for you to go ahead and multiply that puppy out. This is a typical question you could see on the ACT. They do use complex numbers. And I squared being negative 1 is pretty much the Big Mac Daddy that they are going to look for. Not complex factoring. I really doubt that would be there. It could. But I've seen a lot of retired ACT tests, and I've seen I squared on there a lot. And I have seen long division necessary before. Long division of polynomials. I've seen that on the ACT too. One plus 1 root 3, so it's root 3i. I already did that, sorry. Now it's that times that, which is plus I. And then that times that, which is plus root 3i squared. I squared is really negative 1. So now I'm going to have 1 plus the square root of 3i plus I plus negative 1 times root 3, which really makes it minus root 3. Now, have I combined all my like terms together? As much as I can. I mean, that 1 and that root 3 are both numbers, but you can't really combine them because you don't, unless you want them. Yeah, I don't even know how to combine them. You need to know what this irrational number is, which a decimal goes on forever. So that was as good as you could get that one. Again, root 3i and a regular I, they both could theoretically be combined, but you don't know how to add 1 and root 3 together. So, all right, let's do another one that's like that. Actually, we use the same R and Z, except this time, this seems really easy, but the key is you're going to have to make sure you don't leave it in an improper form. This will make it so much easier. I'm going to change the Z. I'm going to change the Z to be 3 plus 3i. Then I'd like you to reduce r over z. We'll pause for a minute while you figure this one out. Okay, I set it up. I multiplied by conjugates. And now on the bottom, which is the key area, we ought to make sure that those i's get out of there. 3 times 3 makes 9. And then outside, inside will cancel. And then the last make negative 9i squared, which really the I squared is negative 1, makes positive 9, and that makes 9 plus 9, and that makes 18 on the bottom. Cool. The bottom is nice and clean. No roots, no i's. If you couldn't get that far, that's one of the areas you need to practice. This was multiplied out, gives me 3 times 1 is 3. Outside and inside don't cancel. Outside's negative 3i, inside's positive. Oh, wait, they do cancel. Wait a minute, that doesn't make sense. Why would they cancel? 2, 3. Yeah, they do cancel. They just do. And then I take that times that, which makes negative 3i squared. And I squared is really negative 1. So then that's really negative, makes it positive 3. 3 plus 3 is 6. 6 over 18 makes 1 over 3. Raise your hand if you got 1/3 for your answer. Awesome. Now let's go back in time and say, I had this. Remember my favorite saying? If you can factor it, you should. You haven't come into it for a while, but do you see how 1 plus I on the top, and this one has a 3, and I got 1 plus I when I factor it out? Look at how fast that would have been. If you can factor it, you should. Comes to save the day again. Would have equaled 1/3 right off the bat. Boom. Okay. See what I did there? I factored the bottom part, and it came out to that. And now the top and the bottom will cancel. Leaves a 1 on top, 1/3. Okay. It's a very powerful saying. It really is. I've seen it. I use it on the ACT a zillion times too. They're just seeing, does the kid notice if this can factor? And then when they do factor it, it becomes easy. Okay, need to pause for a second. So what if you don't know the sides, and yet I still want cis form? And how the heck are you supposed to get the angle if you've never seen the triangle before? You're supposed to know how to do that. I'm going to pause for a second while you try to put that into cis form. Okay, anyway, my instinct would be to grab it. So let's figure out where 1, 7. Over 1, up 7, so there's a dot right there. And again, this triangle just kind of helps me. It's not really there. But I'm making this triangle to help me. That's a 1, that's a 7. And then the other side must be square root of 7 squared and 1 squared, 49, 1 square root of 50. Raise your hand if you had that one right. Awesome. Then square root of 50, does that simplify? Yes, it does, and you should. Root 25 and root 2, so that's going to be 5 root 2. Right? Okay, then for cis form, we need that radius 5 root 2 cis. And then what angle is that? I don't know. So what are you going to do? Have to write it as how you would have figured it out on the calculator. What would you have typed? Yes. Inverse tan. Inverse tan of what? Total opposite over adjacent. I'm pretty sure it's 7. Or 7 over 1. Right? Okay. All right. Now let's go the other way around. Let's say I had 3 cis pi over 6. And I know you could do that by making a triangle. But trust me, you ought to also know how to use CIS form. Because sometimes you can't draw a nice triangle. So what the heck is CIS? Do you remember me saying you could put a little plus in a strategic spot in here and it'll remind you what it means? Where was the little spot where you could put the plus in the CIS? Yeah, C plus IS. And that means it's cosine plus I sine. Okay? Do it this way. Don't do it with a picture, because I'm telling you, you have to know both ways. So write it out as 3 times cosine plus I sine of pi over 6. Those are numbers that you should know because you know pi over 6. You know what those sides are. I'll pause for a second. Figure this one out. Okay, 3 times cosine of pi over 6 plus I times sine of pi over 6, drawing my little pi over 6 triangle. I don't even care what quadrant I make it in because this is just the classic 30, 60, 90. 1, 2, 3, and that's a 30. So then, sine of 30 is opposite over hypotenuse. It's 1/2. Told you we'd do that one like 8 million times, and we did it again. And then cosine of pi over 6 comes from adjacent over hypotenuse, so root 3 over 2. If I multiply this out, 3 times root 3 over 2 plus 1/2 in the I. Then I got to multiply the 3 in there, and I'll get 3 root 3 over 2 plus 3I over 2. Is it good to leave them separated like that? Yes, it is, because then you got your what part? Real part. What about this part? Imaginary. And put it together, you got a what kind of number? Complex. You get the real part, you got imaginary part. Together, they make a complex number. All right. So, I haven't told you everything you need to know for this test, but I've reminded you of a whole lot of things that we've covered. And this isn't going to be a super hard test. This one's not that bad. But I strongly recommend that you do some review. There's lots of practice problems of the kind I just did with you. Look back through the homework and go, ooh, there's one of those kind. I should practice that tonight. But it's your life. If you don't want to practice, you want to roll the dice, it's up to you. That's all I have for you for today.